Okay, so this topic will be on convection, right? Where we will go through this final part for your end of your exams. So now let's take a look at the lesson outcome over here. We will be describing in terms of density changes. So density was a concept that we had covered very early on in this year, right? Where we learned about how to calculate density. So we know density is equals to mass over volume, and we know that substances that has a lower density will rise or will be floating, right? And substances that have a higher density will be sinking. Okay, and this will basically be the basis of how we describe convection, and it will occur in fluids. Now, when I've over here circled fluids basically refers to liquids and gases. So convection in general can apply to both liquids and gases. Please take note and write this down. Okay, so let's just do a very quick recap on what we had covered in the previous part of this chapter. So what is thermal equilibrium? Which can be summed up very nicely using this entire scenario here. Now, so you have A, which is at 80 degrees Celsius, right, and B, which is a blue block at 40 degrees Celsius. So generally, if we were to put these two blocks, okay, side by side and in contact with one another, we would expect that there will be thermal energy, okay, that is being transferred, okay, from the hotter body, which is the block in red, right, to the cooler body, which is the block in blue. And as thermal energy transfers, there will be changes in the temperature. The temperature for block A will decrease, whereas the temperature for block B will increase. Now, as it decreases and increases, it will continue until both blocks actually achieve the same temperature, or they reach the same temperature, and this is where we understand it to be achieving thermal equilibrium. Now, this final temperature that we'll be looking at obviously will be between 40 degrees Celsius to 80 degrees Celsius, okay, simply because once block A loses temperature, or once block A loses energy, okay, the temperature decreases. For block B, it gains energy, okay, the temperature increases. Okay, so it will reach a point where it will be between 40 degrees Celsius to 80 degrees Celsius. Now, it will not be exactly at 60, because there are other factors to consider, for example, like the size of the block, etc. Right? So but we can make this judgment, or we can make this conclusion, okay, that the temperature will be between 40 degrees Celsius and to 80 degrees Celsius. Okay. Second recap will be basically on the idea of conduction. So conduction is a process of energy transfer, okay, where energy is transferred through vibrational motion, and there are two ways that we'll be looking at. So the first one will be the vibration of neighboring particles, basically from one end of a rod to the other end of the rod. The energy can be transferred, okay, from the hotter end to the cooler end, purely by vibration. So as the particles vibrate, okay, and they knock into only their neighboring particles, they will basically pass on or transfer the energy in that manner. So in this case, this is how your thermal energy transfers from the hotter region to the cooler region. Now, there is a second method which is only observed in your solid metal, so please take note, which is your movement of free electrons, and it's a much faster and rapid, okay, transfer method within conduction or via conduction, as compared to your vibration of neighboring particles, which transfers gradually from one end to another. Right? Materials that can transfer energy, okay, we also know them as your thermal conductors. So we cannot just mention the word conduction or conductors, right? You realize that this word conductor is one of the key words that we will need to use in order to explain why certain materials are able to transfer heat much more effectively or efficiently as compared to other materials. We'll always use conductors when we are trying to explain conduction, and specifically we will mention thermal, right? We will not just say conductors, because there are different types of conductors. It could be conductors for electrical or electricity, right? So we have to be specific here and mention that it's thermal conductors. Whereas on the other hand, if it does not conduct heat as well, then it will be considered either a poor thermal conductor, or another term will be the fact that it is a thermal insulator. Right, so that's for the recap part. Let's now move on to look at the actual notes on page 2. So what are the three thermal processes that we'll be focusing on? Okay, we have previously covered conduction in the previous worksheet, and this typically occurs in solids, right? It typically occurs in solids. So in liquids and gases, yes, conduction can happen, but it may not happen as effectively as compared to when in solids. That's one. Convection, which is the one that we'll be covering today, and it typically occurs in your fluids, which I've already mentioned, okay, consists of either liquids as well as your gases. And lastly, radiation, which we will not be testing you all on for this end of year exam, okay, but this will be the third thermal transfer method that we'll be focusing on, and this method can transfer thermal energy through vacuum, right? And it is the only method that can do so, right? So generally, conduction and convection cannot happen in vacuum. Where is vacuum found on in our day-to-day lives? Okay, the space between the sun and the earth. Okay, we'll expect to see that there will be a vacuum. Okay, so let's move on to focus on convection. Convection basically is a process that will involve convection currents, right? So as you can see on the image on the right, okay, there are some arrows going in a circular motion. Convection currents typically will be presented in a circular motion on the diagram, right? And it typically happens in liquids or gases. And the reason why that can happen, all right, is also because of a difference in density. So subsequently, in this chapter, we will also understand and explain what is going on in terms of density. Why is it that density allows, okay, for there to be a movement of the fluid within a particular container or room? Okay, and the reason is very simple, because of changes in the density. Now there will be a three-step answering technique that we'll be adopting in this chapter or in this particular segment. So later on, when we look at the three-step, do take note of how we are supposed to answer it, and please highlight it accordingly in your notes. Now, convection cannot occur in solids simply because the particles are all vibrating in its fixed positions, and they are not able to move around freely as compared to your particles in the liquid or gaseous state. So do take note that when we talk about solids, right, thermal transfer method within a solid, you will not expect to see convection at all. Right, I say again, when we are talking about thermal transfer methods within a solid, okay, you will not expect to see uh, it have convection happening at all. Right, now let's take a look at this diagram over here, okay, where I've already nicely highlighted it into three different colors, and the three different colors will therefore represent the three different steps, okay, that we'll be using. So first off, the one in green, okay, will be the first part where we talk about heating. So heating happens at the bottom of the pot, right, and we will expect that the liquid to gain energy, and there are three keywords or three key things that we'll be looking at. Okay, the liquid will expand, it becomes less dense, and it therefore starts to rise. So this is step one, where the liquid, which is warmer, will expand, become less dense, and start to rise. Okay, number two, okay, once this starts to rise, the liquid at the top will have to go somewhere, and so it will actually go to the bottom and take the original position of the previously heated water. Okay, and that will be highlighted in blue. The denser liquid, okay, which is cooler, will actually sink. Okay, the denser liquid, which is cooler, will actually sink and take the place of the previously heated water. Okay, and it does not just stop there. It's not just a single process where the water goes up, okay, upon heating, and the other half of the container will come down to take its place. No, it does not just stop there. It will continue to repeat because the heating process is ongoing, continues to heat. So in the last part, okay, we mentioned that, okay, the process repeats, okay, and it causes the convection currents to be formed. Right, so as I said, there are three key parts that we'll be looking at. Okay, even in the bottom, when we describe or we attempt to describe what happens during convection, the same thing is occurred. When a liquid is heated, we'll see the same three words. Okay, it will expand, become less dense, and it will rise. So that's in step one. Okay, to explain what happens to the liquid or the fluid as it's being heated. Step two, I'll explain what happens in the top half, okay, where the liquid being cooler and denser will sink. Okay, and finally in the final step, I will mention that the cycle repeats, convection currents are formed. Okay, so if you're not sure, please check in with your respective teachers on this. Okay, let's take a look at one last example before we try the questions on page 3 and 4. Okay, explain how the electric kettle boils all the water inside. So the heat will happen from the bottom, very similar to the previous question. Okay, so let's adopt this CAR method to at least break down the question. So the claim in this case is that the water is heated by convection, eventually boils. Okay, the evidence is because when electric current passes through, the heating element will basically heat up, okay, the bottom half of the water. Okay, and therefore energy will be transferred in the manner. Now, so let's take a look. We're going to adopt the 3-step method to explain this. So step 1, same thing. With water that is heated, I should see 3 keywords. Okay, it will expand, less dense, rises. Okay, in step 2, I'll then need to explain what happens to the water at the top. So the water at the top, which is cooler and denser, will sink. Right, and in step 3, I will not stop there to say that it just happens one time. Okay, so the process repeats, convection currents are formed. Right, please spend some time to internalize these concepts. Okay, and then later on we'll go through the questions in a second video. Right, thank you.